This is the solution video for section 5.2, problem 4C and 4E. All right, so a particle moves along the x-axis in such a way that its position at time t is given by x equals 2t minus 1 times t minus 1 quantity squared. At what time is the particle at rest? During what interval of time is the particle moving left? And then C is what we're going to answer. At what time in the interval found in B is the particle moving most rapidly? That is, the speed is a maximum. All right, so in order to do C, I actually have to do A and B. So at what time is the particle at rest? Well, in order to figure out when it's moving left, I'm going to have to find the velocity and set it equal to 0, and that's part A. So velocity. All right, so velocity is going to be found by the product rule. So 2t minus 1 times the derivative of t minus 1 squared, which would be 2, times t minus 1 to the first, times the derivative of t minus 1, which is 1. And then plus t minus 1 quantity squared times the derivative of 2t minus 1, which is 2. All right, so I'm going to simplify that a little bit. But actually, in order to solve this, I'm just going to set it equal to 0 right now. If we look, we have one term here and another term here. I could actually factor to make this a little easier. I can factor out a t minus 1. So I can factor out a t minus 1, which means I have a 2 and a 2t minus 1. So if I distribute there, I get 4t minus 2. And then I have plus a 2 times t minus 1, so a 2t minus 2. All right, and so I'm going to set each of those equal to 0. So t minus 1 is equal to 0, or this thing, so 4t plus 2t is 6t minus 2 is minus 4 equals 0. So t is going to equal 4 over 6, or 2/3. So t equals 1, or t equals 2/3. All right, so those are the two locations where the, where the particle is moving to the left. All right, so next, during what time, those are the two times at which the particle is at rest. Now, when is the particle at moving to the left? Well, now I'm going to do a sign analysis of velocity. So I have t minus 1, and then I have this other factor, 6t minus 4. All right, so on my number line goes 2/3 and 1. All right, and so then I have my two rows, 0 above 1 on t minus 1 and a 0 above 2/3. All right, and so now t minus 1, pick a number to the left of 1, like 0. 0 minus 1 is negative. Pick a number to the right, like 2. 2 minus 1 is positive. All right, number to the left of 2/3, like 0. 6 times 0 minus 4 is negative. To the right, like 1. 6 times 1 minus 4 is positive. All right, so that means that velocity is positive, then negative, then positive. All right, so when is the particle moving to the left? From 2/3 to 1. All right, but now it says at what time during the interval found in part B, so between 2/3 and 1, when is the particle moving most rapidly? That is, speed is a maximum. All right, so now what we want to realize is that on the interval 2/3 to 1, velocity is less than 0. Velocity is negative. So what does that mean? Well, if velocity is negative, right, so here's our x-axis, between 2/3 and 1, velocity is negative, at some point here, right, it achieves a minimum, which would mean that speed achieves a maximum. So we're actually trying to find where velocity achieves a minimum on that interval. Actually, not a maximum. All right, and so what we want to do is we want to find the derivative of velocity and figure out when it changes from negative to positive between 2/3 and 1. All right, so the derivative of velocity, of course, is acceleration, so v prime. All right, and so if I take my kind of simplified version of velocity, so the simplified version of velocity was t minus 1 times 6t minus 4. All right, so we can use the product rule there to find the derivative. So I get t minus 1 times 6 plus 6t minus 4 times 1. All right, and so this acceleration is going to be 6t minus 6 plus 6t minus 4. And so I get 6t plus 6t, 12t, and then I get minus 10. All right, and so now, in order for velocity to be a minimum on this interval, we need to set acceleration equal to 0. So I get 0 equals 12t minus 10, and so I add 10 divided by 12, t equals 10/12 or 5/6. Now, what first thing we want to do is we want to actually verify that 5/6 is between 2/3 and 1, which it is, and then we need to verify that the velocity does in fact go from negative to positive. So 12t minus 10, right? So a number to the left like 0, 12 times 0 minus 10 is negative, and a number to the right like 1, 12 times 1 minus 10 is positive. So velocity does indeed achieve a minimum at 5/6, which means that speed is a maximum. So at what time in the interval found in B is particle moving most rapidly? That would be t equals 5/6. All right, and then for what times is the object speeding up? So what we want to do, that's part E. I skipped D, so you'll have to do that on your own. But part E, all right, so part E, we're actually just combining the sign analysis for the first and second derivative. So what I'm going to do is I'm going to make sure that I have 2/3, 5/6, and 1 on my number line. All right, and then I put my acceleration on bottom and my velocity on top. All right. And so remember that velocity was 0 at 2/3 and 1, and acceleration was 0 at 5/6. And so I have these intervals. All right. And so now velocity, remember, was, let's see, velocity was positive to the left at 2/3, and then negative in between 2/3 and 1, and then positive to the right. Okay, acceleration was negative to the left of 5/6 and positive to the right of 5/6. All right, so now we match up velocity and acceleration. All right, so what did speeding up mean, or versus slowing down? So speeding up, we said that when velocity and acceleration have the same signs, the object would be speeding up. So object is speeding up from 2/3 to 5/6, and from 1 to, I don't think I gave an interval there, so infinity. All right, why? Because V and A have the same sign.